Okay, guess we can start.
Yes.
Welcome everyone.
Ciao.
Speck&Tech number 31.
Woo! So,
The second of this year, actually.
yes.
You-
We have a couple of free chairs here available. Chairs. There's
Can you raise your
one,
hand?
two.
If you have a
If
chair
you have
next to you.
an empty spot next to you, just raise your hand.
People
So those
there
are the spots
standing.
where also one nearby Albertone. Can I say Albertone? No, I'm fired forever from Trento, sorry.
All the people standing, please come here. Okay, there are a couple of chairs here.
Yeah.
Okay, guess we can start. Is gratting?
Sì, sì, questo termine tecnico inglese.
Okay, Speck&Tech number 31, titled Open Security. Looks like we are a lot into open, because just a couple of months ago we had an event about open source.
Yeah, we're very open.
Very open, very open. So, all the people behind Speck&Tech, all males. Not a
So
talking about...
if you are not a male and you want to help us,
Yeah.
feel free. I mean,
Yeah.
we are all males, but we are very well educated most of the time. But maybe we can improve with a non-male presence. Maybe. I hope.
No, anyway, we are always looking for people that are willing to help us to promote our activities, also to be very willing to clean the room, to help out with all the dirty tasks, but especially also to enjoy and being a big part of Speck&Tech, also contributing to our direttivi. So we start from the lower level, which is helping out at the events, but then we really want to have more people that are active and contribute to our events. So if you're just interested, come to us at the end of the event and talk to any of us, those that are helping Speck&Tech all the events and making it great.
If you're good enough, you can challenge the role of Francesco, which is president. Yeah. Like, that's the ultimate goal. If you want to join Speck&Tech, you want to be the president one day instead of Francesco.
Exactly. Yeah, we're looking for a substitute.
I tried myself as well, but I failed. So.
Okay, first speaker of the night, which is actually the second, Ivan from Russia.
Ciao, Ivan.
PhD student at the University of Trento and of Yeti Digital. He's going to talk about
The dependency hell.
Yeah, the dependency nightmare, so be ready. But actually, our first speaker will be Chris Lamb from London.
Hello, welcome.
So wait. How do you say that?
What?
His topic.
Oh, no, yes, his topic. No, I tried to confront myself with him to understand clearly what he's saying. I'm not sure I got it, but that's what the talk is about. So he's the Debian project leader, and he will talk about reproducible builds. Reproducible
Reproducible
Yeah,
builds.
so that's a beatbox talk. And meaning that you want to be very sure that the stuff you build on your computer is exactly the thing that you want to build on your computer and not something else. He nodded, sorry. But he will go deeper during the talk. That's very easy compared to what I said. So, all right.
Cool. Just before starting, our supporter, we give the word to our nice friends Alberto and Fabio. So, yeah, I would say a big applause to them.
Thank you.
Actually, all of that.
Just 1 second. We are very happy to be here to support Speck&Tech, to be here to see these two guys making their presentations and so on. And I really like the topics, but also the name of today, Open. I like the adjective because the idea is that yesterday DISI was open, our labs were open to the visit of everybody, the students. And today we are open in the sense that we are open to the contributions of this wonderful association. So we are really happy to contribute to what they are doing. So thank you.
Thank you very much.
I guess what we should mention is that, yeah, the ICT days are running. It's going to be a whole month of events. It started yesterday and it's going to run till the 20-something of March.
20.
Yeah. If you just go on the ictdays.nh
ICT.days.
ICT.days.
If you Google ICT Days Trento,
No, ICT Days and that's it.
if you Google ICT Days and that's it, without the that's it, ICT Days, and you press I feel lucky on Google, you end up in the very website of this.
Yeah, and you find that there is a bunch of events that we're also supporting from people that we know, so give it a look. Okay, then we have a friend here, and these are the guys that are making also this event possible, so I will leave the microphone to them for a couple of minutes.
Thank you, welcome.
Yeah, thanks. I'm Davide, I'm working for XPEPPERS, a company based in Trento. You may already heard about us since we talk here at Speck&Tech at the event 8, 10 and 14. So if you missed that, you can still find the video on Speck&Tech website. The news is that we joined the CLARANET company, which is distributed all over the Europe with offices in many places, also in Brazil. And if you don't know us, we are a software developer company, and of course we build software. And we apply agile methodologies, and this is not a buzzword. We actually use extreme programming and DevOps practices to help our customer reach their goals. We also offer training on the topics we use every day at work, like clean coding, testing, DevOps, and we are also AWS training partners. We offer coaching to teams to help them reach their goals inside the companies using agile methodologies. And yeah, we are hiring in our office in Italy, in Trento, but also in Rome and Milan. And what we offer, yeah, of course, money, that's the thing. We are a strong believer that for doing our best, we should be energized. So we try to care about ourselves during the work. So we take frequent breaks because we are using the Pomodoro technique. And for example, we also don't do overtime. It's possible to work from home sometimes. We believe that to do our best we have to study, and so we have at least half an hour every day to study the topics that we like or to work on some personal project. And we also have a budget to spend on books, courses, tickets for conferences and stuff. This is the library that we are building with the books that we purchased in the last years. For the new hires, we have a study path that help them get up to speed on the topics that we use every day. And it's open on GitHub if you are interested to see what we're studying. Maybe you cannot see, but it's a stairway to Orione, the repo. We have water cool stuff like fresh fruit delivered weekly, so you can stay healthy. Free ping pong lesson no matter the weather, and a cool team. And if you want to have more information, you can find us on xpeppers.com. You will also find the open position, and if you don't find something that matches your skills, you can still send an email and get in touch with us. We'll be at the Career Fair event in April for the students, and I will be here later, so if you want to ask some question, I will be probably near the specs and the beer, because we are here for that. And that's all. Thanks.
Thank you very much again, XPEPPERS, for sponsoring our event.
Thanks to Davide for his talk. They're really good guys, and actually a lot of our friends XPEPPERS gave a talk at Speck&Tech. I guess around 3 or 4 of them.
It's one of the best companies in Trento, so I can just recommend that. If you are interested or looking for a position, go and talk to Davide.
Cool. Okay. Giulio and I will be very fast and we recap a couple of things.
Right, we are in Speck&Tech, and Speck&Tech happens most of the time in Impact Hub, which is a co-working space. If you want to work in a place and you don't have a place, come to Impact Hub, and you have 10% off if you mention that you are from Speck&Tech. Otherwise, you pay full price, which is stupid. Next.
And actually, not all the Speck&Tech happen in Impact Hub, but we will tell you about this later.
No, that's a spoiler. Go on, go on.
Okay,
Then, Francesco,
my company is Spazi Dati. We're looking for everyone, basically. So a lot of different roles.
If you know people, send them to Francesco.
Come to us. And I guess, Julie, you're also looking for someone? Or?
Yeah, we're also looking for our special one. Not in that sense, sorry. So Becca is doing mostly interface work, so both on design and development side. We are actively looking for people that knows their stuff around React or React Native, which I know is like saying Java or JavaScript, but still. And no one laughs, very bad. And yeah, that's the thing. If you want to know more, just go to becca.us/hiring or something. Just go to the page. There is the open position.
And then we have Fatturing Cloud and our friends from DigiNet who are the one printing these beautiful stickers. You can find them there at the desk together with our t-shirts. Keep in mind, it's the very few t-shirts that we are selling tonight, probably in the last few events, because we're going to have the 2019 edition that is being work in progress.
Yeah, the old one, we burned them. So if you want an old, like the current design, that's one of the last chances, because then we put them on fire and we film it and put it on YouTube, just to piss you off.
Go there and get them. Okay, you can find all the previous events on our website together with all the previous issues, the talks, the speakers.
The videos.
You can also write us to be one of the next speakers or sponsors of the event. And you can find also some open positions, for example, from our friends from XPEPPERS.
Like if you forget the name of XPEPPERS, you can go to the website and there's written.
And then just go and follow us on Facebook and on Telegram if you want to be updated, especially because, as you noticed, we are selling the tickets for free, but just a couple of days before the event. So you really need to be sure that you get one of them. Otherwise, there's, like today, 100 people on the waiting list that are not here.
Wow. Yeah, we usually write on the Telegram channel, hey, we are doing this.
Yeah. So
in
just
that date, in that.
set a reminder.
Yes.
Okay, final question, how you can donate. You can just go there to Luca, can you raise your hand? Okay, and you can leave a donation. Actually, we were doing something wrong before.
Yeah, we were over-complying. We discovered that you don't need a fiscal receipt with all the boring data that we were using every time. If you want more fiscal information, I can give you the telephone number of our commercialista, but it's very boring stuff. In any case, just go donating. It's now 100% easier. Wow.
And at the same time,
it's our best donation system yet.
and at the same time, if you go there, you can also sign up a small form about receiving free JetBrains licenses, free Flixbus coupons for 20% discounts. And at the same time, we have 2 tickets for PyCon X happening in Florence. And in the next days, we will sort out the winners. So if you go there and you sign up in the form, you can actually be one of the winners, probably.
Yeah, we're going to like a lot of stuff away for free, so please go to the guy. No, I mean, we are not in deep financial trouble, but if you want to contribute, please do. Thanks.
Okay. Final, before leaving the stage to Chris, we have a big announcement, which is actually this stuff here. So we are starting a collaboration with Muse, as we were telling you in the past months.
Yeah, which is a museum in Trento.
Yeah, like very, very close to here. It means that it's an event. It's a series of events, actually 3 events about science and technology. So we are bringing our specosity to them, and they're giving us leave it. And they're giving us their space and also their knowledge, and inviting a bunch of famous speakers. But like one of them was an astronaut. Okay, just to tell you, like I'm not joking. He was a fucking astronaut.
Yeah, and he's born in a place in Austria called fucking. Yeah. That's the thing.
And so keep an eye on our website because we will soon release the tickets. These are the dates: 12th of March, 9th of April, and 7th of May. So you might probably want to jot them down. Otherwise, really be sure that you don't miss those events. Because there's going to be something in between Speck and Muse, not like full Speck&Tech events, not full Muse events. Something in between.
It's like Balto.
Yeah. What the fuck?
He's not a wolf, he's not a dog. It's like bad. No?
Okay, nice man. Code for tonight, slide.do, code st31 or slide.do/st31 to ask all the questions to Chris Lamb, the Debian project leader, coming on stage right now.
Welcome.
Good evening, everyone. Can everyone hear me okay?
Yeah.
Amazing, amazing. Well, thank you very much for the very kind introduction. No problem. I'll try and do that. Yeah, quite a double act you've got there. It's quite impressive. Okay, my name's Chris Lamb. I'm current Debian project leader. Quick things about me. Been the Debian project leader for 2 years now. I'm on the board of directors of the Open Source Initiative, the OSI. I believe my colleague Simon Phipps gave a talk here about 3 months ago. Yeah, I think so. I've been a free software developer for about 10 years. Started as a hobby project, but now most of my work, in terms of paid work, is now in the free software space. So that's really cool. Like you can actually make money in open source and free software. Like you can make a living. Since 2015, I've been a freelancer. So I used to work in the London startup scene, but now I'm a freelance software developer. So things like that. As I say, I'm on the board of the OSI. In my spare time, I sort of pretend to be a musician, just for fun. So I play the lute and the cello, and this is called a viola da gamba, which is sort of a French adjacent instrument. It's quite interesting. So tonight I'm going to talk to you about reproducible builds, and I'm going to tell you about them and why they're useful and relevant through a tale of 3 developers. So sort of developers like you and me and things like that. So the first developer I'm talking is Alice. So Alice is a sort of free software developer. She writes some software in her spare time, or maybe it's a full-time gig, but just in her spare time. And she offers her code available on her website, her software available on her website. And you can download the source code, or you can download some EXEs, dev, RPM, this kind of thing. It's just convenient, just to get, if you wanted to try her piece of software out, and you didn't want to spend ages compiling it or working out any issues and things like that. You just want to download some pre-compiled binaries. Makes sense. So you have the choice. And then one day she gets a knock on the door, and this chap turns up and says, "So, that source code you got there, and the exe and the dev RPM. So what I want you to do is, well, I'm not asking you to do anything, just suggesting. If you don't want anything bad to happen to your house, your dog, your family, just saying. That before." Keep the source code the same. Don't publish. Don't make any changes to GitHub. Not asking you to do that. But before you publish your exes or your debs, just make this very small change. It's very, very small. Trust me. It's very small. So yeah, so she's essentially blackmailed into making this small change to her source code before generating these binaries. And so therefore the source code does not therefore correspond with the binaries that she's offering. So someone looking at the source would be like, well, looks fine. Cool. There's nothing in the Git commit history that suggests otherwise. But when they actually run and install those EXE or RPMs or whatever the distribution is, something interesting might happen. Who knows? You know, this is someone else's idea of what they want to run. Talking about Bob. So Bob is he's a sysadmin, pretty geeky one. You can tell by the rather silly mechanical keyboard. I bet it's really loud, and I bet he was banned from having it in a co-working space. You know, some of those really clicky ones. I don't know why he's got this sort of podcasting gear. I guess whatever. This is the joys of you know, just getting clip art from the internet. Anyway, Bob is a sysadmin for a large Linux distribution. Let's just call it Debian. You know, why not? And unbeknownst to him, his servers have been compromised. His local machine has been compromised, and someone has used that to modify the Debian build system so that whilst people are uploading source code to be built that ends up in the Debian distribution, the source code again is absolutely fine. People are just uploading it. Great. This is a new version of Apache, a new version of GCC, a new version of whatever. But the version of the compilers on his servers, because he's been hacked, the compilers that are running on these servers are adding some extra functionality. You know, just like with ours. You know, just before they've taken the source code, and instead of generating the normal binary at the end of it, they will be adding some extra functionality or extra features, maybe some backdoors to the result. And this gets distributed to end users. So here's the compilation process going on. And when the users do run a sort of a apt install, whatever, Apache, whatever, whilst the original source code that the developer uploaded was absolutely fine, no flaws there, it ends up that the actual code that people are running on their systems is modified by the compilers that have been compromised in the central build system. So this is our third developer, Carol, but we're not actually going to talk about Carol. We're going to talk about Eve, and Eve is who's called what's called the evil maid attack. So whilst Carol, you know, goes down to the hotel bar, the lobby, goes down for breakfast or whatever, Eve is the evil maid, and the evil maid, because Carol left her laptop there, the evil maid installs some extra software on her computer. And this is a problem because Carol, you know, is quite a good friend and with lots of people, and she likes to distribute code to other people. So this is her giving out a Linux distribution or just whatever. Just like, hey, check out this Ubuntu thing. It's pretty cool. Check out this. It's kind of cool. Giving it to her friends. But unfortunately, because her computer's been compromised, the actual code that she's sharing, the actual the software that she's sharing with friends is compromised as well. You know, so it could violate the privacy of her friends. It could send their credit card details to someone random. You know, this kind of thing. Basically, not stuff she intended to. And I'm not sure if you're aware, the 4 freedoms as embodied by the Free Software Foundation. The third one is the freedom to redistribute copies so you can help your neighbour, which they call freedom 2 because they zero index them, you know, because they're geeks. So, I mean, so you can help your neighbour. This is talking about it in a different sense, but in a more general sense, are you really helping your neighbour if you're installing malware on their machines, even if you didn't mean to? So, yeah, not good. So what's the general problem we've got here? So the general problem is that once we can view the source code for malicious flaws, we can download the source code for, say, Nginx, as I said earlier, and we can look through it and we can pay someone we can analyze it and things like that. Most users are installing pre-compiled software. I mean, when was the last time anyone here used something like Gentoo or something like that? A while ago, maybe. Does any Gentoo users in the house? Well, there's usually one. Okay. Yeah, so most people are installing pre-compiled binaries. So this is apt install blah, yum install blah, or they're downloading an exe from for a Windows machine, or even installing things on Android, or iPhones and things like that. There is obviously source code that you can analyze, but people are installing pre-compiled versions because compiling. It's 2019. Come on, guys, let's stop compiling stuff. So, yeah. But so can we trust this compilation process? Can we trust that we can get from the binary, from the source to the binary? Okay. I mean, this isn't a hypothetical attack. I mean, is the kernel.org Linux repository was compromised? You know, something that should be fairly well maintained, I guess. The Free Software Foundations was attacked. Apache was attacked. FreeBSD, PureFFD, yeah, there's quite a few of those. Yeah. I've stopped collecting the screenshots, but yeah. So basically, it's not necessarily sort of this sort of pie in the sky theoretical attack. It actually does. So, yeah. So what's the solution? So the solution from the reproducible build solution is we start with the same source. So this will be this will come a bit clearer later. But we all say, okay, given Nginx version XYZ, you know, whatever that is. We then make sure that whatever environment you build it in, whenever you do it, whoever does it, whatever machine you do it on, you always end up with the same result, like identical results. So the files are literally identical. So given the same source, and you compile it, you end up with the exact same file, whoever does it and whenever they do it. And then we all compare results. So you might use SHA-1 sum, or you might just literally compare files and just see whether they are actually remotely different. So this is probably a bit too small, but this is David. He generates an Nginx build, and he comes up with the checksum that starts with 7A48. Okay. This is Aaron. Aaron does the same thing, also compiles the same source, ends up with a binary that has the same checksum, 7A48, blah, 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 blah. Okay, they correspond. Then Fred, he does the same thing. He gets the source code, same source code, compiles it themselves, and gets a different checksum. It starts D0F. So he's getting a different result when he builds. Now, if he starts with the same source, and he's got the same for the computer, then we can start to be like, well, is Fred's machine compromised? Is Fred's compiler adding in extra things that he shouldn't? Is Fred lying to David and Aaron and saying, oh yeah, I've started with the same source, but I've actually snuck in my own secret things, and then compiling? We don't know. But because he's got a different checksum, we know that the resulting binary is not the same, and so we can flag up that it warrants extra perusal and things like that. So how does this help? In the Alice case, the blackmail is uncovered. So lots of people will download her source code and compare the results of their build. Now they all should get roughly the same results because they're, in general, people's machines aren't compromised. So they say they'll come up with 7A48 or whatever the checksum is, and they all agree that if you build Alice's piece of software, you should get 7A48. But if Alice is distributing something with a different checksum, in other words, she's generating and distributing a piece of software with a different hash, then something else is going on. Like those things don't correlate with her. So yeah, worthy of extra attention, and the blackmail will hopefully be discovered. In terms of Bob, the same thing. The compromise will be discovered. People will be building the software themselves, comparing results, and then comparing them to what's coming out of the build farms that we showed earlier in that lovely blue clip art. And when they come out to be different results, they'll say, why is this? What is going on? And people will investigate the build farms and be like, oh, it's been compromised. Okay, we can detect that way. In Carol's, exactly the same case. Her tampered laptop will be discovered in exactly the same way. So this basically reduces the incentive to attack in the first place. If you're blackmailing developers into doing something, and your blackmail will be uncovered fairly quickly, it sort of kind of defeats the point in the first place, because the idea is to keep it on the down low, as they say. So yes, by reproducible or identical, I don't mean we build with the same dependencies, so this doesn't mean fixing your versions in requirements.txt and things like that. I don't mean reliable builds, so sometimes it accesses the internet or does something a bit strange in the build, things like that. I mean that every time you build it, whatever machine, whenever you do it, 10 years in the future, etc., you get identical build results. But wait, is the software reproducible already? I mean, when you run GCC or when you compile some C code and then you recompile it again, don't you get the same result? Well, it turns out you don't. A whole bunch of reasons why. Let's just run through them. So if your build process uses the non-deterministic ordering of, say, a hash function or a map data structure, say, in Java and things like that, then the build will non-deterministically or randomly come up with a different result each time you build it. So it won't be identical, and you can't play that game of compare the results because the build process will just sort of be random just by design. If the same thing with if there's any parallelism, if there's any overlapping in timing between threads and processes, you get the same issue there. With timestamps as well, software loves to embed timestamps in the result. You know, I was built on this day. Great. But that means that if you build it on a different day, you're going to end up with a different result, and you can't play that comparison game because you can only play that for that particular day or however, whatever the resolution of that timestamp is. Same with build parts. If you build it on your machine in home/Lambda or home/Fred or whatever, if that gets embedded into the final result, then it's going to be different for everyone, and people can't play the same comparison game. Same with file ordering, etc. There's all sorts of other environment stuff that can sneak in as well. But are there any other advantages of reproducible builds? Turns out there are. One thing is that if your build always comes out to the same result, so if you build it, press up, enter, and get the same result, that means when you make a deliberate change to the code, the source code at the beginning, you're going to get a very minimal difference at the end of it. That's generally tends to be true. This is very useful for when doing, say, security uploads or where you want to push a change to a large number of machines in a very safe way. You don't want to make a small change and end up with lots of inadvertent changes being pushed out to production. You just want the exact change that you made to be in production. Say you're updating the code for a hydroelectric dam or a nuclear power station. You don't tend to be sort of cowboying and messing around there. You just want to just change exactly what you want to change, get out of there. And a reproducible build will mean that the small difference in the original code will generally end up with a small difference in the final code, which makes it easier to check by hand and things like that. Very useful for quality assurance. When you have a build that's always the same, you get about a cache hit ratio, which saves time, money, CO2. There's a certain well-known search engine that saves quite a lot of time, energy, effort, etc., and greenhouse gases by adopting reproducible builds because things just build faster, because I don't need to rebuild because I'm going to get the same result because reproducible builds. Yay! You can also use it to remove build dependencies or other things you don't want in your compilation process. So, for example, if you build once and then you remove a particular feature and you get exactly the same result, well, that feature obviously doesn't do anything, so you can remove all of that code. Great, you sort of start to, minimalism is good, that kind of thing. You can also find some bugs. I will skip over some examples of these, but here's a security bug that I found where the build kept embedding a different random secret in every time they built, which meant that every installation of that piece of software shared the same secret, kind of a bit boring. This was one rather random, non-deterministic memory corruption error, and this was flagged up by our reproducible builds testing. It ended up finding a bug in this documentation generator. And here was a rather strange piece of software that generates test data that gets fed into other programs, and it failed to build 0.46% of the time because it was generating, you need a bit of factorial combinatorics in maths, but it ended up that if you every 0.46% of the time it would fail to, the test suite would fail because it would fail to generate a list with enough unique elements in it. Yeah, kind of silly and fun, but yeah, you basically can find more sensible bugs as well. So I'm going to talk very briefly about Debian reproducible builds. Debian runs a sort of what I call the torture test. So what we do is we build a piece of software in two wildly diverse environments to deliberately flag up reproducible issues between packages, reproducible issues in the package itself. And the idea is that if it passes the torture test, because it's so extreme, it will mean that in the everyday usage you'll end up with the same result. You know, if I build it and you build it, we should be fine, because the torture test is so extreme. And we vary all sorts of nonsense in this, so we build, one build is built now, you know, just, and then we have another set of machines where the clock is set a couple of years in the future. And then we build it on that one and we compare the result. And if there's any timestamps, they'll obviously be, that gets embedded into the binary. Then they'll end up in the that binary, and the build will be marked as unreproducible. And we change lots of other stuff, the file system, the time zone, all sorts of stuff, and that often flags up very interesting differences between things that we then fix, and therefore things will be reproducible in a normal sense. We first did a rebuild in 2013, where 24 packages are reproducible, and of March this year, 93–94% now are reproducible. Here's a graph of our progress. So sort of green is the number of percentage of reproducible packages. It's gone down here because this torture test is subject to constant revision. We're constantly adding new ways of varying the build between A and B. And here we added a new type of variation. And so we immediately dropped. So any packages that were subject to that variation therefore became unreproducible. And then we added a fix for most of them, so that white jumped up again there. So, yeah. The other thing you notice is that the entire graph is moving up to the right. That's because Debian is getting bigger underneath us all the time. Yay! So you can go to isdebianreproducibleyet.com to get a, it's like the how many people are in space right now. You can see, basically see the current percentage and things like that, and that gets updated every so often. The project now is way beyond Debian, though. We have a whole bunch of other distributions, particularly Fedora, OpenSUSE, Lead, F-Droid, very interested in it. A bunch of other sort of new style functional operating systems like NixOS and Geeks, and build systems like Maven and Maven as well in the Java world, and such like that. So it's gone way beyond Debian, so this is not a Debian project anymore. And there are other people using what was originally Debian's testing framework to test their own packages. We've had 3 or 4 summits where we all get together from all the different distributions. So we had one in Athens, 2 in Berlin. We recently just had one in Paris in the Mozilla offices there. That was really, really good. So yeah, we want to talk quickly about a tool we developed that's very useful for developers in general. So we were finding that when we were comparing packages that were unreproducible, in other words, we had 2 bits of code that were binary code that was different, we were finding it difficult to work out the reasons why they were different. And so I'm just going to run through, this is the normal Unix diff utility. You give it 2 files, file 1, file 2, and it tells you what the difference is between them in nice colors. So file 1 contains, this is the first file, this is the second file. That's great, but then if you run it on 2 binary files, you get utter nonsense like this. Like, yes, that is the difference between those files, but it's pretty meaningless. So basically, we thought we should build a better diff for this particular purpose. And we did. We called it Diffoscope. And to read the slides here, Diffoscope will try and get out on what makes files or directories different. It recursively unpacks archives of many kinds and transforms various binary formats into more human-readable forms. So this basically means that you can give it almost 2 any completely weird files, and it will try and tell you sort of a human-readable difference between them. Very useful. So you can give it 2 zip files, and if the zip file contains a file that's got another zip file inside it, and inside that there's a file that's different, it'll tell you exactly that, instead of just giving you this sort of ugly nonsense at the top like that. It supports HTML output, it supports all of these file types, and you can go to, if you want to just try out very quickly, you can go to try.diffoscope.org, upload 2 files that are similar but different, particularly binary ones, and it'll give you a rather nice human-readable difference between them, and not that ugly binary. Diffoscope's very useful for showing, when I said about doing minimal differences, it's very useful for that. The diffoscope is not the definition of reproducible. If a build is reproducible, it's literally identical. So diffoscope is not needed to tell you whether a piece of software is reproducible or not. It's only sort of useful, or we only use it as a way of quickly finding out and identifying the exact differences when there are differences. If there are no differences, then it is reproducible. So yeah. Diffoscope is also useful for comparing binary blobs. So when you get a new router firmware, things like that, from Netgear, they just provide that as a precompiled binary. And you can, if you compare two of those using diffoscope, it'll tell you the real differences between them. You can see what they've changed between them. It's very interesting peering into it. Otherwise, it becomes sort of an opaque blob that you're like, well, I'm updating this software from that to that, but what's actually changed? Who knows? So what's left to do? We have a whole bunch of other stuff. Source code itself still remains vulnerable. So if your source code contains errors, backdoors, weak algorithms, it's using MD5 or things like that. Codes with testing modes, this is a reference to VW Gate, things like that. If your source code is dodgy in any way, reproducible builds won't help you, because it sort of assumes that the source code is fine. So if someone has stuck something into your GitHub repository that's malicious, then well, you may have a reproducible build, but it's a reproducible build of some malicious software. So that will help you. The other thing is how to expose this to end users. If they are installing a piece of software, it's not guaranteed to be reproducible. Does it start to say the following packages are not reproducible when installed anyway? This is a bit strange. People don't understand the concept intuitively. I mean, this is copied from the authenticated one, so if you're not downloading from a trusted source, I think everyone can pretty much intuitively grasp what that means. But when it says reproducible there, it's difficult for users to parse, so that's still unknown. A bunch of changes still need to be made in some tool chains. So, for example, the GNU C compiler still needs a bunch of changes done to it. OCaml, Go, Erlang, there's a whole load of them that still need work. We need a way of infrastructure changes so people can share those checksums between them, things like that. The solutions there are as yet unknown. And improving the developer tools as well. Diffoscope is good, but we still need to do work on it, because in a lot of cases it's not possible to understand it in many ways. Sometimes it falls back to a rather silly, naive way of comparing files. And then there's sort of policy changes as well, like we could say that a package can't be in Debian unless it's reproducible. That would make sure a lot of things, people gave their attention to the right place. And so if we change the policy there, that could help there. These are unknown questions, things like that. And then also there's things about defeating the trusting trust attack, which I'm not sure people have read that paper, but it's a fascinating thing of what if the very first compiler was compromised, and every single one from then the 1970s has also been compromised, but you can't tell. You know, this is sort of theoretical things like that, which I might be interested in working. So yeah, if you want to get involved, visit reproduciblebuilds.org. You can follow us on Twitter at reprobuilds. You can join the Reproducible Builds IRC room on the OFTC network. But yes, thank you very much. Grazie. And if there are any questions, very happy to take them.
We had me here actually. Okay, thank you for the talk. Lovely. Okay. Cool. Couple of questions. People, you can write them on the link that we share with you on the Telegram channel, or otherwise we just shoot them here directly to us. First question: do reproducible builds help with software preservation, e.g., software heritage?
I can guess who's asking this one actually. But I don't think I'm not sure they necessarily help with software heritage. As I understand, the Software Heritage Project, it's a way of archiving a particular piece of source code and etc. in it at a particular time, so it's not lost. Because often, a build system, GitHub may not be there forever. I mean, GeoCities was going to be around forever. Now it's not. as I understand it, software heritage is addressing those concerns, and that may be useful as a source of source code when you want to reproduce a build from many years ago. But I think those are slightly orthogonal projects. So, yeah.
Can you think, in order to avoid adding extra features, about compiling the source code server side and then sending compile.x, etc. to the user?
That could work. Unfortunately, you're now trusting the server side build process to be completely pristine and fine. And if you remember the Bob example, it was Bob's servers that were actually compromised. So people were literally doing exactly that, sending the source code to an external compromise thing and getting back a binary, which you therefore can't trust. So yes, unfortunately, that's not the solution.
Is there a way to trick the hash?
To
go around the hash?
There's one way you can trick the hash, is that if your machine is compromised, then you can't trust anything it says. So if you ask your machine to give you a hash, then you can't trust it. So yeah, there's that one. That's probably the most common one. There are obviously hash collision attacks. So if you are using a poor hashing algorithm, you may be able to find, I forget the term, when you have a collision between two different files end up with the same hash. Yes, so it is theoretically possible that, but the main one is if your machine is compromised.
Did you discover any malicious tampering in the Debian archive?
Not yet, not yet. Yeah, not yet, no.
Looks like it's quite an effort to make a build reproducible. Why instead making the building environment safe and reproducible, e.g. using Docker?
So Docker will still generate unreproducible packaging. Docker can remove a whole bunch of sources of non-reproducibility. However, it can't do them all. So if your build process literally embeds timestamps of the current time of day, then Docker won't help you there. Also, to mandate that people use Docker to build a piece of software may not work, because if you want to do this in 10 years, will Docker still be around, etc. Also, there's a bunch of legacy systems that just can't mandate Docker. So Debian is a very old operating system, and so to mandate that every build uses Docker would be a little arduous and a bit hard for a lot of developers to swallow.
Yes, actually another question was, does Docker with its Docker file achieve a similar result? I would say his final question, NixOS recently achieved 19% ERC13Y on their base image. What do you think about functional package management? Do you think the majority of distros will adopt it?
I don't think distros will necessarily adopt functional package managers in the completely strict sense. So I don't think they'll be using exactly some of the tools, but I'm sure they will adopt some of the lessons from it. So instead of having, for example, having scripts that get interpreted and executed when you install, they're using much more declarative styles in general, because that just is sort of better from a sysadmin point of view. So I think there'll be a lot of concepts that are stolen, but will they just outright adopt the Geeks package manager? I don't think so, and particularly not with distributions that have a whole bunch of legacy installations like Ubuntu, Debian, and things like that. The change would just be too big. It's like asking, oh, why don't we just get rid of apt and RPM and all use the same one? It's like, well, that would be great, I suppose, but like, it's just not going to happen. So, yeah.
Okay, thanks Chris again. Big applause to him.
Thank you very much.
There's actually another number of questions, so people will probably ask you during the break. 5 minutes break, kids, and then we get back for the second talk.
All'ingresso l'ho lanciato a sparare.
Sì.
Yo, 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 yo. Please sit again. Hey, hey, hey.
Strunke en Bottom, yes. We come too far. Please sit down on the chair. Grazie. Hello, Speck&Tech is resuming in approximately 1 minute. Please take your chair. Mind the gap between the train and the platform. We are now approaching to the next guest.
Okay, people, wait a second. Before Chris is leaving,
Ciao, Chris.
everybody say hi.
Bye. Thank you for coming. Thank you very much. It's been a pleasure.
Let's go back to London. All right, second speaker.
Yeah, we're almost everyone's seat. And try harder. The hardest. The very hardest. All right. So, I hope you're ready for the second guest from PhD in TRENTO, Ivan. Thank you very much. Welcome. Thank you.
Thank you. Hello. Hello, everyone. So it's really nice to see you here from this side, from the stage. So yeah, I'm Ivan, and tonight I'm going to tell you about the dependency hell. So we are going to understand what it is and how to say no to it, actually. So a couple of words about myself. I'm Ivan. I'm doing PhD in University of Trento in information security. I'm also the passionate follower and attender of Speck&Tech. I attended like 25 events, and after that I was like invited to speak here, so it's very nice. Yeah. Thank you. Thank you. I also like to play volleyball, and in free time I also go to do some hikes and to do snowboarding. And that's basically saying that I like mountains. Yeah, so I like Trentino, and I put here this picture because I think these mountains actually remind me a software project. At least the software project as it was like maybe 15, 20 years ago. Well, at that point of time we had like all the code stored in one place. So basically everything was inside. You can see it, you can touch it, and you can like everything you have in your hands and your control. It's basically one piece of rock. So like all code is here. But nowadays software projects actually looks a bit different, and I think they look like more like icebergs. And so what you see here, the old code, it's just the very top of the iceberg, and behind, like underwater, it's software dependencies. So let's try to understand what the dependencies are. And when we are talking about dependencies, we basically mention a piece of software that relies one on another. Well, to the programmers to understand this better, then it's basically the separate packages that are distributed via Maven for Java, then via pip system for Python, and via npm for JavaScript. So when I'm talking about dependencies, I'm meaning exactly these things. And why would we actually use them? So because when we write code, we don't want to reinvent the wheel. We don't want to re-implement the same functionality again and again. And so we basically just import the things that are already implemented for us and incorporate them in our projects. And I mean, that's very comfortable, and that's why we want to use it. We may use it once, then we really like it, so we use it like 2, 3, 4 times, and this is still fine, because that's the thing that that's basically in our control, that we see from our projects. But the problem starts that the developers of these packages, they still think that in the same way as we do. And they also want to import some functionality from somewhere else. And that's why they also use dependencies. And the developers of dependencies of our dependencies also use dependencies. And so all of a sudden we end up with a picture like this. That's actually the dependency graph for a real project. So on the sides, which is not really visible, are the libraries. And each connection between them represents the dependency relation. And so I officially welcome you to the dependency hell. That's how it looks like. And so, of course, all this became possible due to open source. And it's used like everywhere now. So we will all know these projects. And a lot of studies say that open source used like everywhere. So for example, this is the recent study from Black Duck. And we have, we see that 78% of companies run on open source. Then this graph is actually pretty interesting. We see that the number of government users like skyrockets in GitHub. And that's, I think, pretty funny. And of course, this leads to the exponential increase on the number of open source projects available to us. And I mean, it's really amazing. It's pretty cool until we face some security issues, like, for example, in the case of this company, Equifax. So this company, it's an American company. It managed the data of American citizens. And so they had such information like names, surnames, addresses, social security numbers. And well, of course, they had very, well, this data is really, really sensitive, and it's like personal data. And of course, they had very strong requirements to their to their development, to their source code. But one day, it happened that all this data became available to everybody. Basically, from 143 million Americans, it's just imagine the whole population of Italy and Germany together. And if you have this data, you can do whatever you want. You can create, for example, you can make a loan for every one of these guys, so it's pretty sensitive. And though all this happened, and just imagine, their code was almost perfect. But what they didn't look at their dependencies. And that's why they had a 9-year-old vulnerability incorporated through transitive dependency. And this led to this kind of thing. So we don't really want to end up with this kind of situation. And so let's look closer, let's look inside software dependencies. So this is the dependency tree, at least how it looks like. So on top we have the library that we are working on. So that's our code. And below, what we directly reference from our project is our direct dependencies. So here I just explained the notation. And the dependencies that are referenced from our direct dependencies are transitive dependencies. So, okay. And, well, just for you to get an idea, that, for example, if vulnerability comes from, like, we know that vulnerability may come from the transitive dependency, so we should not only take care about our own code, but also about the safety of all our dependencies. Well, there are quite a lot of them, and so let me give you some idea on how we actually can do this. So, the zero step is basically that you follow, so you just subscribe to the social media of these libraries, and you basically read some emails, you receive some notifications of the updates that these projects push from time to time. So you just see, okay, they released something, and then you check their change log and do this. Well, you basically need to go through a lot of spam and do a lot of manual work in this case. But believe me, a lot of people do not go here, and those who actually check dependencies, they just stay on this step and do not go any further. Of course, there are a couple of ways to automate this process, so because it's kind of boring. And the first one, thanks to GitHub, we have this functionality. So we have the possibility to build dependency graphs. So we can just enable it directly in our repositories on GitHub, and we'll receive this list of direct dependencies. So you remember, we have dependencies of the first level directly referenced from our project. And then we can just click on one of them and drill down and see the list of direct dependencies of that one, and so on and so forth, so we can just try to explore it. A little bit more of automation we may have from the tool. By the way, here I list some, I give some links about the mechanism behind it, so just because after that I'll share the slides so you can just go through them. And so, come back, here's the tool that allows to have a bit more of automation. So for example, this one, Sneak. This tool supports like several languages, several build systems, and the best thing about this tool is that they open their vulnerability database behind it. And it means that their researchers, like day by day, they go and they check the code and vulnerability of the library, so they put the correspondence, like what is this? So they basically fill this page, so they put their data like the severity of vulnerability, some description, the version range, and also they say how you can mitigate it, how you can fix this vulnerability here. That comes from this kind of library. There are a couple of more tools that you may use. Like is SourceClear. This tool also works with a bunch of projects, but it's commercial, so they do not give you anything for free. The other one is Vulas. So this tool is open source. They have a very good, very precise code-based matching algorithm, so they produce very precise results. The problem is that they support Maven and partially Python, so they do not go above. Then for Python, we have this option to use safety library or PyUp service that they released. And for NPM, we have the out-of-the-box support of the last version. So we can actually run NPM audit, and it gives you the list of your dependencies and also provides you with some information about the vulnerabilities. Okay, cool. So basically we have some automation. And so what? You take one of them, you run on your software project, and you receive this. So you receive this kind of a report which says, well, I have some high severity alerts, some medium severity alerts, well, maybe some low severity alerts. In this case, we didn't have like that. But so what? What should I do with them? Well, most probably I will need to go through all of them and try to understand what's actually going on inside, because we cannot really use this information. So we did this for you, and we made some observations. And the first thing that we actually found that not all libraries are the same. So you see, these bugs do not really see such scary like the others. Probably because they are coming from the dependencies that use only for test purposes. And this means that these guys, they do not actually affect the library when you build it and ship. So they will not affect your customers. And that's why, well, there are still vulnerabilities, but they are of low priority. So we can just postpone fixing them at a later stage. But with these guys, we still need to deal with. Okay, our second observation was about their direct and transitive notions. So the typical perception that what we can fix and what we should be fixing is basically our own code, and we should do something about the direct dependencies, the thing that we actually reference from our project. But again, not all libraries are the same. And so if we look a bit closer, then we see that some of them, for example, these two, Y1 and Y2, they relate to the same projects. So they are released as parts of the same project. What does it mean? It means that they are developed by the same team, by the same people. And so if the guys update, for example, Y2 to the next version, this means that they release the new version of the whole project. So you automatically get release of the version Y1. And so you can use it actually on the other way around. So if you want to fix this vulnerability in Y2, so you can directly update your direct dependency Y1, and you can fix this vulnerability here. That's why we were saying that, well, the direct and transitive notions, they are not precise, so maybe we can use these kind of notions. So we have the libraries that related to our project, like our own libraries. Then we have libraries that we can directly control from our project. And then we have, well, we still have something out of direct control. And our third observation was, well, we found that everybody dies. Yeah, and so the software libraries do. So, okay, let's look here. So, this is the structure of three libraries, M, X, and U. And so, as we see, that's the M is our library, so we develop it. And so it depends on the first versions of each library. So it depends on the first version of library X, and which in turn depends on the first version of library U. And this is the situation at time t0. So we have this point of time. But then, if we have a situation that our direct dependency X dies, it means that it's not supported anymore. It doesn't receive any more updates. And apparently, we see that version U actually received some updates, so it received a new version. And we will be actually glad to receive this new version in our library at some point of time. Well, maybe not today, but maybe like in 10 days or something, maybe in half of the year, like in 1 year. But we would be glad to have it. But this will never happen, because this just dies, and therefore our new version would still depend on this last version, the first one, this case of library X, and we still have this outdated transitive dependency U. Well, this is dangerous because, for example, this if we have vulnerability in library X, then it will never be fixed, and so we will need to deal with it by ourselves. But even more dangerous, that's well, this library is alive and it still receives updates for bugs and vulnerabilities and so on, and they are being disclosed. And therefore, so for example, on this point of time, we will know that this one is affected by vulnerability, but we will not be able to fix it. And in our mind, we will be sure that, well, we are totally fine. In our project, we specified the latest versions, so I mean, we are good. So we do our best, and we can't do anything like here. So we just should wait for this library to update, but it will never happen. So this kind of a dangerous situation. And yeah, so the mitigation of this situation is possible, but it requires some costly thing from you. So yeah, and what's the solution for this? So we propose we propose a methodology on how to address all these observations. So the first step is just to incorporate the functionality of a build system. So to receive the dependency tree. For example, in case of Maven, we just use these Maven goals and we receive the dependency tree. Then we filter out non-deployed dependencies. So we remove the test alerts from the picture. Then we group dependency by projects. And then we identify the dead ones, the halted dependencies. So for this we have this methodology that is based on the release dates, and then we map the left libraries in the dependency trees. We just map with known vulnerabilities associated with software libraries. And for this, we use this precise matching algorithm introduced in this paper. And so let's look at the effects. So the first step, filter non-deployed dependencies, allowed us to reveal 20% less false alerts to check. So just imagine, we have 5 days working week, 20% less work, so we have Friday for free. Then, dependency grouping step. So, the typical perception, so you remember the title of my talk, Dependency Hell, so we cannot really do anything inside. But what we see here, that we can and should, as developers, fix 82% of the alerts in the dependencies. And that's a lot. So yeah, it's not actually such a hell, so let's say no to it and go and fix it. So the halted analysis, well, we have 15% of dependencies that are halted, that are dead, and maybe they not introduce the problem now, but we may end up with a problem later on. So, coming back to the report, so we transform it, so instead of 3 numbers we give 4, but here we give some meaning to these numbers. So, okay, in total we had 38 alerts, as before. Then 30 of them are deployed, so affected our customer, our user. Then, then the 26 alerts we can and should fix by ourselves. So we should go and check these 26 guys. And then the last number is the number of halted dependencies. So at some point of time, we should dedicate some time, some development resource to maybe change this library to an alive one. And that's what we do. So we bring order to the dependency hell. So we remove some mess and yeah, and we generate these kind of reports. So we well, currently it looks like this, but the cool thing that we actually show the point to fix. So we direct a developer to a specific library, so we can just look at it, this component, and then change the configuration file there. And well, this thing works. It works pretty well, but we're still looking for improvement. We still want to have your feedback. When we want to receive your experience about the way and your perception of software dependencies. So how you deal with them, how you address these kind of problems. So please, if you have some time, contact me. I would be happy to chat with you and exchange our opinions. So thanks a lot.
All right, thank you. I was very impressed with the part everyone dies. That was actually quite a turning point. So if any of you have a question, we are happy to reply to that now. You can use your sliders right in your pocket, in your cell phone, you know, the smartphone, the one that blinks all the time with notifications for social networks. And
Or you can also give it to me, and I can go around.
or you can use your mouth, your physical body, like the mammal you are.
I actually have a question. You said that it works pretty well, this algorithm. How can you say that? I remember you said something that you tried it with companies or something. Can you tell us a bit more?
Yeah, we developed it together with one software partner, and so we also tested it on like a bunch of open source projects, and we found that it's pretty stable, so it works well.
We're not filming, we're not live.
They're recording me there.
Yeah, no, they do are.
Yeah, perfect.
I actually, it was pretty clear also to me, which I'm not super nerd. I'm actually very happy to see Speck&Tech nerdier than usual. We had a lot of entrepreneurship and design and less like developer-oriented stuff, which is nice, but also, I mean, there's a tech in the name. So, all right. If you are very shy or hungry or you want a beer, which could be the case, yeah, I don't see any question. I would really like to thank you for the very clear presentation. I also myself don't have any question, which is usually not a thing. And yeah, a big applause for everyone. Thank you very much. Also, he's a regular speaker, so I'm very happy to see him on stage next to us. You can be the next one as well. Just send your candidature, your candidatura, which in English is submission.
Candidacy. Yeah.
Candidacy, thank you. So not to be confused with candida, which is very bad. So, I'm actually totally sober, which was the question of Professor Montejo. And yeah, so
I think it was a pretty good invite to.
What?
Yeah.
No, I'm a natural. So yeah, please don't forget the next events are not here. So I'm also trying to remember for myself, which I will be totally here.
On the 12th of March.
Everyone is tonight.
On the 12th of March, remember we will be at Muse. You will get all the details in our Telegram channel. So pay attention to that. And yeah, I hope you're not on the waiting list, but you're actually in the beautiful audience that we expect at the museum. So I guess we have just a couple of things to say before closing. Of course, remember right there's the donation table. You can go there and help sustain the foundation. The more funding we get, the more beers we get, which is also a good compromise, I would say. And finally, yeah, some of you are sitting on a number of different chairs, and we need all of your help to stack them and to pile them up right here. Give me a second. Okay, so all the people sitting on the red chairs, please pile them up and put them here on the front of the room. The people on the black and on the orange one, back then at the end of the room with Emanuele. The green one go inside here in the ripostiglio.
You will be guided by Michele, the most handsome of the group as usual.
And all the chairs that you cannot find a solution for because they are too fucking weird, you just drop them here in the corridor, okay?
But please, before, do a little dance.
Okay. Cool. Enjoy the night and the
Thank you
beers
very
on
much.
stay.
See you next time. Bye.